everyone. I'm Sohini Roy, Product Manager at Canonical, and welcome to Ubuntu Masters. I like to think we save the best for last. Today it is my pleasure to help share an interesting story of how to achieve and be really successful with HPC, high-performance computing, with multi-cloud. The times are changing, and highly efficient systems at a lower cost is just critical. We're about to share from our guest speaker today, Eric, on how he was able to achieve that competitive edge for his company, Scania, with some really powerful tools. Be sure to stay around for the end, where we'll go through a demo of how to set up and deploy the key tools you'll need in just 10 minutes. In our new working from home environment that we've all adapted to, I'm sure everyone's very comfortable with webinars, but just in case, be sure to check out the attachments that we will be sharing at the bottom tab, as well as the questions tab that you'll find there. And we'll be able to answer all of those questions towards the end. And if we miss any of those questions, we'll be able to follow up afterwards.
Hello and welcome to the session in Mastering Multicloud for HPC Systems. My name is Erik Lönroth and I'm the technical lead for Scania HPC Systems and been working in that particular role for about a decade now and gained significant experiences in various fields that surrounds our industry. I've also come to work with a bunch of software systems beside of that touches on cloud technologies, infrastructure, and a lot of open source component that constitutes what is today a modern data center. So I will start, of course, with a bit of an introduction and gonna introduce you to some of the component that constitutes in HPC systems, and I will also introduce you to one of the problems that traditional HPC data centers are facing today. After that, briefly going through some of the key components that we need to address this particular problem, and finally we are going to dive a little bit deeper in and how we are addressing this particular problem with the setup that you will hear about today. I hope that you will stay with us for the whole session. It's going to be roughly 30 minutes. And the subtopic today is like deploying and operating SLURM as a snap with Juju. So this is me. My name is, as I said, Erik Lönroth, and I've been the technical lead for the Scania HPC systems for about a decade. I have a Master of Science in Computer Science, so my background is primarily from programming, I guess. And that has led me to various adventures within the software industry. I've been a software entrepreneur, also be part of a startup company in Silicon Valley called Impact Vision, along with some other engagement that is within the software world. I am a heavy advocate of open source software, and I've been a board member, and I'm now a board member of Open Source Sweden, which is an authority of software systems in Sweden, dealing with open source questions from a legislation kind of perspective, but also from an industry perspective on the particular topic. I built a portable IPv6 connected flamethrower. I have two wonderful kids roaming about here, and I'm also the maintainer of the Nextcloud community charm on Juju that you might want to check out in the link over there. And I'm not on LinkedIn. I value my privacy in that context, and you can instead look me up on my WordPress page, which is eriklönroth.com. So that's a little bit about me, and I'm going to continue now with talking a bit more about HPC systems. So, high performance computing, or HPC systems, has been around for a very long time within industry, and primarily addresses large problems requiring many times multiple computers to solve complex problems. Within an automotive industry, it might, for example, be how aerodynamic forces interact with a car in such a way that we can reduce that by understanding how that works. And for that, it requires a significant amount of computing power. So HPC systems are typically basically a lot of servers interconnected by high-capacity networking, and on top of that, we run specialized applications such as MPIs or similar. So SLURM is a very important component into high-performance computing today. So SLURM is pretty much a software system where that has the purpose of putting large workloads onto a shared resource, because not all jobs are equally large, and they also require different resources, sometimes on many different dimensions. And those resources could be like storage, they could be licensing, networking, it could be various of GPUs, and it could be pretty much anything that you can imagine exists within a data center. So the role of SLURM in our context is to basically play that very intricate game of Tetris to fit the various of workloads that goes in and out of an HPC system. There's really no magic around HPC. It's just it's like a scheduler in the Linux kernel to schedule, instead of processes, you schedule large amount of workloads running on multiple computers. So demystifying HPC is kind of important, because it's for a very long time it's been very like a few selected persons that understood or understand what HPC is like, but that's completely not needed anymore. I think HPC workloads is becoming exceedingly mainstream, but the tools and components are still very old, and that is partially part of the problem that we're trying to address going forward with the systems that I'm going to present to you today, or rather maybe like the approach to the whole field that we have taken over the last few years. So yeah, I'm going to continue now to explain a bit more about one of the particular problems that we are trying to address. Right. So one of the problems. So consider having a large amount of servers to your disposal to run your existing workflow. Typically in an HPC systems, those computers that you have access to would not be virtualized. There's a good reason for that. Basically, if you look into now modern cloud environments, for example, they share most of them share the property of basically using virtualization technologies and hypervisor to come around the fact that you might need multiple instances of an operating system, and utilizing the fact that the normal server normally runs at a very low load. But using virtualization, you can basically cut up the same server into multiple servers, and by that increase the total amount of workload that you can have on one particular server by the means of virtualization. That problem does not really exist in an HPC systems, because the software that you typically run on your operating systems will consume the full capacity contained within one particular hardware server. So your hardware server will be 100% utilized. Splitting it up into multiple of virtual systems makes really very little sense in this context. Right. So however, virtualizing and adding your data center becoming software driven, so primarily working with virtualized resources, adds a lot of flexibility. So public clouds are really attractive in that sense, that you can start and stop and create new instances by the means of kind of a self-service manner, where all of those components can be built to suit your particular need. That is a very attractive feature. But if you intend to use your particular instance in a public cloud, you end up in a problem. Basically, that you have to pay per use, and that model is very expensive if you use a high degree of resources onto your particular hardware. And typically we talk about large servers here. Have multiple maybe hundreds of gigabytes of RAM memory, maybe up 30 or 40 cores, or they're a really large service anyway, and you have multiple of them. So you can imagine your public cloud bill is going to explode in your face, but you still want that flexibility. So once your compute cluster is full, you're running it at 100%, there's still going to be a demand at some point when you simply do not have the amount of iron needed, but you're faced with a deadline. What that means is that people dependent on getting results out of your compute systems will have to be in a queue, in a line, waiting for resources. And at some point, at times, that waiting time is unacceptable to your deadlines. But since your hardware is all depleted, what can you do about it? You can't do anything about it. You need to, you need to wait in that line. That situation, you would argue you wouldn't end up in that situation if you're running in a public cloud. But then you're back to square one because it's too expensive. So what do you want to be able? What is the problem? Well, how can you offload into other clouds when your capacity has been depleted? That terminology, that process is called offloading. So offloading is kind of the Rosetta Stone to HPC. How can you do that with simplicity? Because that has proven to be a very difficult problem to most HPC systems. There are a bunch of problems tied to that particular activity, such as moving data. That is one thing. You have to transfer sometimes terabytes or even more of data that is part of your simulation. It needs to be moved to a public cloud, and also you need to move your supporting infrastructure around running your HPC workload. That could be, for example, license servers. It could be auxiliary systems needed for maybe like material database or integrational points, or it could be a lot of auxiliary systems that you might need to move, and that maybe is not possible easily. So that is the particular problem, how to accommodate for the offloading situation, and that is a very difficult problem. So to understand now what we have done with this to address this particular problem, I'm probably going to have to introduce you to a bit more about the various components. But before with that, I can mention that there are a lot of other problems, of course, that is related to running an HPC system and offloading the capacity. You have the maintenance of sometimes like multiple operating systems. There could be Red Hat systems, it could be CentOS systems, it could be Ubuntu systems, it could be pretty much any operating systems that you would like that would add flexibility, and that is very difficult in an HPC system where consistency across the executions is sometimes needed. We're also talking about different CPU architectures that would introduce you to additional problem space. Yeah, consistent dynamic configuration, scaling up and scaling down. How do you do that with your offloading? What's the principle around that? How do we provide access and security to these systems? Because of sometimes we perform simulation on stuff that is really cutting edge from a research and development point of view, and in other particular, within other industries, it might be medical information or even information that is tied to GDPR, which is like an integrity legislation within the European Union, etc. Yeah, and of course it's the everyday operations. People that needs to help and assist in resolving problems within the environment. Also, tracking and resolving errors that occurs, broken hardware, degenerated performance. Yeah, you know the deal here. And of course how to work with that over time in maintaining the performance for an high performance computing. So as you see, the problem space is fairly large. So let's talk a bit about the principal component in solving this particular offloading problem within HPC. So the principal component is Juju, and explaining to most people what Juju is has proven to be very difficult. Juju is a very large tool. It's a framework, it's a client, it's a server component, it's basically a tool set. It's been many attempts to describe this well, and there is a site that is dedicated to the purpose, which is https juju.is. Juju is. So I would really recommend you to visit that site, because I will not dive too deep in what Juju actually is, but to me, and for the purpose of explaining this in this session, it would be a framework to consistently operate software system in any cloud as code. So it addresses like 4 very important workflows, or things. Is that you can deploy the software. Once you have it deployed, you use it to operate it. It means that you will, it means that you can perform actions on your software where from outside of the software itself, to do stuff with it in a consistent ways, in such a way that you don't necessarily need to know everything about your underlying software. And it helps you to do that for the lifetime of the system itself. So it will help you through, it will give you the primitives and assistance to, for example, perform upgrades, or maybe back up and restore. And that is totally dependent on your underlying software, of course, but Juju is there to help you with that particular activities. And also, very important, it does so using programming as code. And it does not, also very important, where Juju distinguishes itself from other software systems, it does not impose that you need to have a domain-specific language to solve your particular problem. And that means in another wording, that if you are a good programmer in, let's say, Python, which is the most common programming language, you're not bound to it, but if you are a good programmer, you will also be good at running Juju and operating it and doing stuff within the Juju world. And that is, of course, very attractive when we talk about automation. Automation, which is also key when you're running large computer systems, sometimes with thousands of servers and many different sub-components to that on a software layer. So Juju basically, this is what Juju do for you, what it does for you. Some of the components might be worth mentioning. It's that it rotates very much around something called charms, which is basically an encapsulation of software into a deployable package, if you like. It's pretty much like an application package format for systems. And you can there's a concept about relations that allows you to connect these systems with each other. But I will not dive too much into Juju. I would highly recommend that you start using it if you're not already doing that, and if you're active within the DevOps domain, or if you feel that the world is getting exceedingly difficult maintaining a lot of different and complex software systems, Juju will be your savior. So I can't really stress how much this has done to me, and also a lot of other people working with this computer domain. Okay, anyway, I'm going to proceed now to explain to you what Juju needs. And Juju needs clouds. So, clouds. To talk about clouds, pretty much the current paradigm that we live in rotates around clouds, really. It's the reincarnation of the old data center, I would say. If you're running your data center activity today and have not yet converted that into a cloud-based platform, you are one generation left behind. You need to start moving in that direction, and that is exactly what we did, starting with a large project to transform our HPC data center into an underlying MAAS. Underlying cloud, of course. But yeah, okay. So we already talked about when we introduced ourselves to the problem, and also what the HPC systems meant, that you are running primarily on physical servers, where you avoid the overhead of putting a hypervisor in between you and the application. So in terms of clouds, there exist many. Of course, you're very much familiar with the public clouds being essentially virtualized clouds. What is MAAS then? So, well, MAAS is a hardware cloud. Simply put, it's a cloud where the underlying VMs are physical servers instead of virtualized ones. Yeah, so that is MAAS. And it's important to know why we chose MAAS as our underlying cloud for an HPC system. And I've already told you about them under that kind of what reasons from a performance and resource point of view that was. But it's important to know that MAAS supports the primitives needed by Juju. So Juju needs the cloud primitives that MAAS provides, and it allows us to put something that is called a Juju controller inside of a MAAS, making it available just as if it was, for example, an AWS or Azure or Google Cloud Engine cloud. It basically provides a cloud to Juju, but in this case, it's hardware. Typically, what you do in a MAAS is that you can configure networking aspects of your physical servers. You can choose different kind of operating systems of Ubuntu, and maybe CentOS is also supported natively, and you can add your own custom images or operating system. It supports a bunch of other operating systems as well. So it's fairly dynamic, although at glance it shows itself to be fairly primitive. But this is all you need from a Juju perspective. And again, I will not dive further into what it is. It's an infrastructure as a service component constituting a cloud, and that is what you need to understand why we're using it. Moving on, now we're jumping from the cloud and Juju into the third component, which is snaps. Right. So what is a snap and what's that? Why do we need it? So we have talked about the problem and some of the sub problems to being able to offload. One of those sub problems is consistency. Imagine yourself having one Red Hat system and one Ubuntu system. It turns out that the package maintainer of SLURM, for example, that is a very key component. Is the key component in HPC. It turns out that SLURM is packaged in a various of different kind of ways, if you like. Not a single packager provides SLURM the same way. That poses a lot of problems if you are running workloads that crosses boundaries of operating systems. It could be that you're running different versions, for example, of SLURM that will make the whole execution of your processes impossible or very error prone. Consistency is extremely important when you're dealing with high performance computing. Also, when you have thousands of instances running particular software systems, also being able to perform upgrade in a consistent manner, where you're also capable of reverting, is a very good feature, and that Snap provides with its atomic upgrade principles. Oh, and of course the means to encapsulate this software with its dependencies. This is also very important when you're providing features onto your SLURM clusters or your HPC systems, that you're sometimes dependent on other software systems that you need to have following along with your installation of let's say SLURM in our case then. And of course, last but not least, it adds a very modern security model where we are suddenly allowed we're suddenly gaining quite a bit of a security layer around our execution of our applications, and that is a very good feature of snapping. So we decided for a long time ago to work with a partner called Omnivector Solutions, so that provides like the unofficial snap for the SLURM workload manager, but that really cuts into this software stack very nicely, and we're approaching a state of that is extremely interesting, where we can get all of these features together with Juju and MAAS in a way that is attractive to an HPC kind of business. So I'm going now to continue into the last piece, how we all build this into something that is useful. So all in all, we've been talking now about, except for the MAAS cloud, we talked about three important components. It's the Juju charm or the Juju framework. We talked about the snap format and what it does for you, what it adds to our equation, and also SLURM, of course, as a software system that is key to HPC systems. So what we do here to make this very, very consistently and then also deployable in any cloud is that we take the Juju charm that encapsulates SLURM. We put that into charm, and by that suddenly any computer in any cloud on most Linux distributions supported by the underlying cloud on the underlying CPU architecture suddenly is deployable and maintainable and operatable, and basically gives us all of those features that we are looking for to build a modern HPC system in a very cloudy way. And so this is how then we put it all together. In step 0, we have our internal MAAS system running on physical hardware to the left here. You see, I'm not going to introduce you to any particular SLURM commands or something like that, but if you would type in commands at this particular state, you might be faced with having 0 nodes available to you because 100% of them are in use. That would basically be a system that is now queuing up workloads, and perhaps you have that situation when you need capacity. So then you're looking towards those public cloud providers. Maybe that would be AWS or Microsoft Azure, or it could be pretty much anything else that can appear as a cloud. What we do then is that we use Juju to provision and move the complete infrastructure into either or both of those public clouds. And that decision could be based on either economy, for example. If you know which of those clouds are more cheap than the other, then you select that one. Or maybe you have some performance requirement that is better met by any of those cloud providers. Then you use Juju to deploy into those. And suddenly what would be appearing at your own data center, or at least from your workload kind of view, is that you now have an equivalent infrastructure that you're used to. It will be looking exactly the same as it did when you started this, reducing the onboarding activity, the time when you can actually get someone being productive in a public cloud where you normally would otherwise need to learn native tools that exist in these clouds for HPC. But in this case you don't. You just continue to use SLURM, which is like the common denominator here across all HPC systems. So you deploy SLURM then into AWS or Azure, and that will be then readily available for you to offload. And of course, ideally then those resources would be immediately put to 100% work so that you could decommission them after your offloading activity has been solved. And essentially you would have solved your problem. Yeah, this would be more expensive, but it would be only expensive for a limited amount of period while you're waiting for your internal data center to, or where you're offloading your internal data center in such a way that you reduce the waiting time in your queue to an acceptable level. Okay, so before I start showing you a small demo deploying SLURM into multiple clouds, I want to take the time to sum up a bit of this session. First, MAAS. Yes, MAAS has the needed properties that you need for a core private infrastructure for HPC. We use Juju to deploy onto those, and it could equally be used to deploy on private, public, and hybrid clouds. That addresses the offloading problem, so in such a way that you can meet deadlines while still maintaining your cost control. Users continue using the same tools they're used to, which reduces the time needed to perhaps learn native tooling. And the same is true for administrators that can continue leveraging their existing HPC skills. And finally, using SLURM in the Snap version allows you to deploy SLURM also very consistently over multiple operating systems, perhaps even on different CPU architectures and even your laptop. So now I'm gonna show you a small demo showing how this might actually look in real life. So the demo that we are going to go through now consists of 4 parts. So first we're gonna install the Juju client. We're gonna use the Juju client to bootstrap a local LXD cloud existing on the laptop. We're gonna use then Juju to deploy SLURM in both the local host LXD cloud and also equally into AWS. Okay, so the first step is then to install the Juju client with Snap, of course, and as you see, that process is fairly quick. Then, moving on, issuing the Juju bootstrap command to the localhost cloud. And to the right, we are going to watch now the LXD instance coming to life. So the bootstrap command launches now a LXD container to the right side. We shall see it come up there. And that is actually the first machine in our cloud now, which will then be injected with the needed Juju API endpoint capabilities. That process is normally taking maybe 1 or 2 minutes for the machine to be spawned, and prepared with the agent coming alive and get prepared. So we're gonna skip forward in our demo a few minutes, so you don't have to wait for that process. It takes about a minute or so. There. At this point, the Juju API endpoint, also called the Juju controller, is about to be ready. There. So this allows us now to validate the functionality by issuing a Juju models command. It basically shows us that we now have a working Juju environment. We add something called a Juju model here. Adding a Juju model is basically creating an empty environment for us to place something such as SLURM into. So the Juju SLURM core demo model was added. You see it now appears in the list of models. So let us now see the actual process of deploying SLURM. So at this point we use Juju deploy SLURM core. SLURM core is an existing environment in the Juju charm store that contains all the different charms needed to deploy the current version of the SLURM system that exists in charm store. We're not going to go into a lot of details about that, but a SLURM cluster actually consists of multiple components such as a MySQL database, a controller, a DBD system, and also of course an executor node like a SLURM node. All of those instances are now spawning inside our cluster. To the right you see the LXD instances on the actual laptop coming to life. Worth mentioning about this process is that this is a very good way to develop SLURM and SLURM capabilities inside of your own environment. It allows you to basically create your own personal or your private SLURM cluster also with Juju, which is useful if you want to add in other features like network file systems, or if you want to add in, I don't know, NTPs, or maybe your own personalized charms. This is a very, very efficient workflow in testing out capabilities or functionalities before you actually deploy them onto your MAAS system or maybe your private clouds. This is also a process that would obviously take some time for the instances to come alive and configure themselves and joining up to the cluster, and we're going to skip that part also for you to see that we're going to be able to start this also on other clouds. So I'm going to skip ahead while this is actually executing. It normally takes about a few minutes. So while we are waiting for the localhost SLURM cluster to come live, we're gonna turn our eyes and deploy the same thing in AWS. So you don't strictly need to maintain your own controllers if you're going to use a public cloud. So in this case, we're going to make use of the JAS. So we're going to switch into the JAS controller, which is hosted by Canonical. That gives us immediate access, for example, to AWS. So let's do the same thing. Let's add a model to the AWS. So at this point, we now have an empty container which we can place any infrastructure, but of course we're going to deploy SLURM. But for that, we're also going to add some network capabilities that we want to be able to use, showing off a bit more advanced use case of Juju. You don't need to do this strictly, but in this case we're going to show that you can use customized bundles. Maybe in this case we have a core bundle with NAT capabilities. This will of course then be interesting because you can use maybe your SLURM instance from external networks. At this point you see Juju is doing pretty much the same thing as it did when it was deploying into the local instance. At this point you can see now we're back at the localhost controller, which is the laptop version, and you can see here that the SLURM charms and the SLURM environment is executing various installation procedures and taking care of all the things that is necessary to produce an operational SLURM cluster. You can see versioning over at the left corner, and you can see what kind of state the various of the components, various of the like the DVD or the MySQL, and how that is coming to life and what kind of state it is. Very useful when you want to understand or when you need to customize behavior of your systems. Well, we're not going to go into too much about that, but you can see here now that the local host instance is slowly coming to life. You can see some wording about relations here, like missing relation or whatever that is. That's Juju basically telling that it might need to wait for additional components coming to life before it's actually possible to form up a cluster. These are all details going into Juju, and you don't need to know the details, I guess, for this particular purpose or at this particular point. Basically, we're looking at a cluster coming to life at this point. Okay, so now we're back and looking at what's going on again over at the left corner, the localhost, and we can see what's happened to the right in this particular cluster, and we can now see we're switched to the right hand side, and we can now see that we have the AWS model instead that is looking very much alike the left hand side, which is the localhost. You can see they're very similar, although these different models has reached different stages of its spawning. But as you will see, and eventually when all of this is ready, they will be all green, looking good and active and ready to, you know, be our SLURM clusters. So you can see the process here is identical, apart from few differences in terms of how you want to networking it to behave and such. And that actually proves also some of the flexibility that exists within the framework itself, that you might want to have different kind of environments behaving a bit differently, maybe on a network level, maybe on a functionality level, or if you need to add in different kind of integration points depending on which cloud you are currently working with it. So Juju has all of these capabilities, and what we're seeing now is that we're making use of some of them. Yes, as you see here now to the left side, on the local host, the LXD cloud, Much of it is now green, and only the last piece of the configuration of the SLURM controller is taking place. And now, as you see, it's going to be green across the board in seconds, and we have now an operational SLURM status. Yeah, so this pretty much, you've now deployed your local host SLURM cluster, and to the right hand side you see that the AWS instance is coming alive equally. A word about this is that, of course, bringing up and working with multiple models can sometimes be fairly daunting. You know, once you get a hang of working with Juju, you end up having very many computer systems running at the same time. But the modeling of Juju and its different entities allows you to keep track of all of those models within the list of your current active Juju environments. They're also called models. So you end up working at the same, maybe with tens or maybe even more different SLURM clusters, and that would be a very daunting challenge for anyone working with large computer systems. You know, keeping track of all your different environments for different purposes. But Juju helps you with that. There are even some GUI, web GUIs now that assist you in keeping track of maybe tens or maybe, I don't know, hundreds of models, given what your particular use case is. Yeah, and as you see now, also the AWS instance has completed its installation and deployment cycle. Coming across here, on the right hand side you see it's got to get up and becoming all green nicely. So at this point we have actually achieved what we were set up to do, improving that we can use Juju to deploy SLURM and HPC stack on a laptop, and also equally in a public cloud, in this case AWS. And as you see here now, we're going to have two identical systems, or three SLURM environments, showing us that we actually have multi-cloud setup with Juju, localhost, and in the AWS in the US West 2 region. Well, that was pretty much it. Thank you for watching deploying SLURM in a multi-cloud setup using Juju, MAAS, and the Snap version of SLURM. I want to pay some attribution to a few mentioned open source contributors. Thank you so much for providing all of these components. SkedMD for SLURM itself. We have Canonical for Juju, MAAS, Snap, and making that all open source. OmniVector Solution for developing the SLURM charms and Snap and making all of that open source. Scania, that dedicates its HPC resources for this groundbreaking work in the HPC area, and also for its excellent strategy promoting community involvement within open source. I want to thank the Juju open source community. There are so many talented people working with this community at the moment and in creating really state-of-the-art software. I think this is something it can't be emphasized enough. And of course all the countless of independent developers and computer scientists that makes all this work possible at all. Well, my name is Erik Lönroth, and thank you so much for watching this session. I hope we can meet in person and speak about all of these exciting development within the computer industry.
Wow, power of open source, huh? Definitely be sure to check out those resources from Eric, the discourse page that can be found from juju.is, where you can connect both directly to our engineering team and some super talented, brilliant minds in the community. It's really some interesting stuff that's being developed there. I've seen a ton of questions coming in with some of the biggest themes that I'm hearing or seeing from these questions is we want to know more about scalability. How can we improve scalability in HPC? Is there any possibility for offloading, for example, where we need to increase scalability in runtime, maintain the workload? how would you think about scalability there, Eric?
Mm. It's a good question, actually. So normally HPC workloads would be limited by primarily the networking capabilities, and not only networking in a strictly with Ethernet capability, because normally you use high capacity networks. I addressed that early in the presentation. And normally you run it on high bandwidth, low latency networks that are very expensive and also very difficult to scale because of distances. So it's if your computer center, your private computer center is located locally, but your cloud is maybe located miles away, you're going to introduce a latency factor, which becomes it becomes a problem.
Yeah.
So normally you have let's say like local networks consisting of typically InfiniBand that would be primarily the limit for your scaling capability locally. But that doesn't mean that you can use public clouds to scale out anyway, because you could easily start a fairly large cluster onto some of the public cloud providers that today actually have very attractive and very low latency networks within themselves. So you can utilize that to get fairly good performance. And we've done some tests on that, and it looks very promising. Although it comes with, as everything, it comes with additional problems, because those are native and maybe not, you introduce other problems. But again, this kind of setup will simplify that process a lot. You could actually address the scalability issue exactly the way that I showed in the presentation, by basically spawning a temporary SLURM cluster and use that particular piece of the puzzle to maybe offload some sort of, some amount of your workload. And that could be totally integrated within your local data center. So yes, you can address scaling in that particular manner, but scaling across networks that are sometimes very, very disconnected and primarily in terms of latency, then is still an unsolved problem. And yeah, we could go very deep in that. There is some research on this actually. Getting reliable networking in terms of latency, but it's still an unsolved problem.
Something we're still working on.
It is.
Yes, very much.
Very good question.
Yeah. And keep them coming. I'm just looking through another really interesting question. The big buzzword, it's not even a buzzword, it's just the biggest theme that we're seeing generally, Kubernetes. Why are we not using Kubernetes to control the Lexi containers? Any thoughts on?
I'm not sure I understand the question entirely, but I'm going to try anyway. So first of all, so from a Juju perspective, Kubernetes will be just another cloud, I guess.
Mm-hmm.
Well, you could use Kubernetes as a platform to deploy your workloads if you're into that. I know that Kubernetes is rapidly becoming like an industry standard for many AI workloads that are exceedingly becoming very, very similar to HPC workloads. Yes, I've listened a lot to Andrew NG, he's an authority within AI. He talks a lot about the integration between AI and HPC. And of course, Kubernetes is going to play an important role there, and Juju is there to facilitate that, to make that also, again, consistent, because normally you would have to use Kubernetes in a very Kubernetes way, but Juju could, lower those differences, if you like. I haven't used it myself, I will happily admit, but I know eventually I'm probably going to end up there as well. But there is no reason really, not why we wouldn't be able to use serverless, or why wouldn't we be able to do that? It's just not been explored to my knowledge yet.
Yeah, I will say there are a lot of folks who leverage Kubernetes with Juju and do similar. So I think it was just a choice for you guys at Scania to go with what we knew, go with what we already knew that we would do really well. So definitely something to be explored. And I think if you want us the community, maybe in a follow-up session, we can talk about how folks are leveraging Kate's a little bit more with Juju.
Yeah, what I've heard and what I've seen, and again, I'm not really competent enough to tell the entirety of this, but to my knowledge, Kubernetes still lacks a scheduler which is more advanced. That's what I've heard. Maybe it's not true anymore, but Juju is the scheduler here. So maybe, oh, sorry, not Juju. SLURM, for example, is a scheduler. So I would be very interested to see where is it true that is maybe SLURM capable of filling out a role here in the Kubernetes realm as a potent scheduler. But I'm not sure, and I'm not sure because I don't know enough about it. But that could be something also which touches base.
Yeah, and well, speaking of SLURM, I'm seeing some questions here as well. A little bit more of a clarifying question, so we can just double back on this. Is SLURM creating containers on public cloud or full VMs, functions for serverless computing? Would that be cheaper? Just kind of, if you could clarify that really quickly.
Okay, so yeah, totally. So the SLURM doesn't really do anything with the cloud because SLURM can't do anything with the cloud. So Juju, however, is capable of spawning EC2 instances, for example, in AWS. And I guess those would be fully virtualized VMs, of course. But again, Juju could equally spawn Kubernetes, right? So, and Juju can spawn LXD's container already onto this. And I know that, I think that that AWS has the capability of actually also provision even physical nodes. So first of all, Juju will take care of that particular step, instantiating your underlying VM first, be it being a fully virtualized node, a physical node, a process container, or maybe an LXD or something like that. So Juju can do all of those, would say, like types of virtualization of a VM. And then on top of that, you would place SLURM. But SLURM would not, SLURM wouldn't be aware of if it was running on a physical node or in a container. SLURM doesn't care about that.
Yeah, and another interesting question, can we shift workload from private cloud to another private cloud? And how do we tackle securities with that? And I think that's something we could do pretty easily. I don't know if you want to share your experience.
Well, as soon as we venture into the realm of security, I would say, well, best of luck. Security is a very, very challenging topic in terms of. So that aside, of course, shifting or moving from one private cloud to another private cloud would be easier, of course, than maybe the reverse here. But again, the way you use Juju is you move your infrastructure. You're not moving the cloud, if you like. You're moving your infrastructure to the cloud. There is a saying like if Muhammad can't come to if the mountain can't come to Muhammad, I guess Muhammad have to come to the cloud. So this is kind of the approach here. You move your infrastructure, and moving your infrastructure is far easier than moving your users, for example, across multiple clouds. That's a lot more difficult, actually. So I don't know if that really answers the question, but yes, by moving infrastructure in this way using Juju, it becomes an easier task than moving everything else. But again, there's no free lunch here. You still have to move your data, which is sometimes if you're dealing with multiple petabytes or data, your transfer cost is going to be an issue. So you're still going to have to manage that particular situation, and then it comes. Why would you? So cloud. Yeah, I could venture a lot into the complexities around this, but cloud also comes with a bit of a catch. It's that there's a massive lock-in factors of going into a particular cloud because of the transfer costs, and also because of your infrastructure rapidly becomes very you rapidly become dependent on native tools, and then suddenly you can't move your data, and then everything just blows up. So, and Juju kind of helps you with that. It doesn't solve it, it doesn't solve some of the problems related to that particular scenarios.
Of course, but I think one thing that we do really well is taking one framework and applying it across multiple clouds, and that level of flexibility. I mean, you and I have talked about this a couple of times about how do we establish consistency across multiple systems, and how you're leading that charge at Scania. Do you want to share a little bit about that story, about how you've been driving automation, and what you're hoping to achieve across the business?
Yeah. Oh my God. Yes. Okay. So I'm stubborn. I'm stubborn. So it means that so Scania is over 100 years old. You know, it's a really, they know how to make really good trucks, really, and IT sort of came along, and Scania has been implementing software, you know, since there were software, but it means also that you have a fairly large legacy, and that is probably true for most large companies, especially of aged, you know, and what that means that you have to treat your old system, you have to deal with a lot of legacy systems while still trying to keep up with this immense speed that the software industry is keeping up with today. Okay, so I think it's too much to say that we're actually leading this development. We're not, but we're exploring it. It means that we're trying to use Juju and this platform, and I'm trying to teach a lot of people that are still struggling with legacy system how they can use Juju to simplify some of the tasks that we are today doing with the traditional system administrative ways of working. So I used to divide I try to clarify what we used to do and what we're doing. We're doing a lot of system administration, and that is a very expensive activity in terms of time, in terms of complexity, in terms of not being able to, you know, automate fully. There's a lot of stuff that comes with that, and people are still using I would say Ansible, which is like everyone is using Ansible. Yes, of course, it's an amazing tool. But the thing to me is like it's still one decade. It's a decade old or more. So I'm trying to explain that we need to automate much more. We need to automate our infrastructure. We need to automate everything we do in every possible aspect. And Juju is that kind of automation framework, to me at least, and it's helped me a lot. And I don't really understand why I should use Ansible for anything anymore, because I do it with code. And that is a bold statement, I guess, and maybe it's me that I don't know enough about Ansible and how great it is, but I have not yet, maybe I skipped that part or something, but okay, so anyway, so Juju is that automation framework, and I'm trying to teach Scania why that would matter in the future, and even as we are now, you know, today. But I still feel a bit uncomfortable saying that we're leading this development, but we're certainly trying to keep up.
Well, I think it's still fair that in look, change is hard, especially in big companies. In new companies, it's equally hard for its own set of rights. So I'm also seeing some questions about getting started with Juju, some of the differences between Ansible, SaltStack, and some other things. I know we're right at the end of time. You've talked a little bit about Ansible and how they could pair with Juju. They absolutely do. I know you're leveraging it as well as Juju, and I know a lot of people who are using the two together. Hopefully we'll post one of our blogs as an attachment in the tab at the bottom. If not, we'll post it in the Telegram channel that I think it splits out the differences really nicely. Juju is open source. You can start trying it right now. Super easy. When we send out the demo, you can follow along with the demo that we just shared today. So definitely do take advantage of that. Open source, you don't need to pay for it. Any other questions, Eric? Anything to add towards the end as we wrap up?
Well, no, not from my part, really. I'm happy. I can see that I'm really glad to see some newbies question people that consider themselves new to this, and I am very active in the Juju community. And it's just, if you show up there, I'll help you out, definitely. I think that it adds a lot to the whole community, and Juju community in the whole. It's a really welcoming community. So that would be maybe my final thing, to just if you want to hook up that and learn much more about that and continue improving on this, that's where you go, to the discourse.juju.is, I think it's moved to, but there's a discourse over there somewhere. You'll find it.
You'll find it. And then you'll find all of us. We're all super active on there. Our engineers love that as their morning routine. Instead of Twitter or Facebook or Instagram anymore, they go straight to discourse. And that's where we're living now. So one last reminder that if you liked it or have advice for our session here today, please be sure to leave a review. We're excited to bring more folks to talk about this. I'm seeing people saying thank you from all over the world. That's always really nice to see. Both of us are in 2 different countries, and the person who organized this is in another country. So we've got this really great global team, and we love to stay in touch. So do let us know how we can continue to keep growing this. And thank you so much for your time. Bye, everyone.